Here we have a problem on indices. That is, if x to the power of 1 by p is equal to y to the power of 1 by q is equal to z to the power of 1 by r, and x, y, z is equal to 1, then find the value of p plus q plus r. We have two information. So this is the first information and this is the second information. So using these two information, we have to find the value of p plus q plus r. Okay, let me take the first information, that is x to the power of 1 by p is equal to y to the power of 1 by q is equal to z to the power of 1 by r. Okay, now these three quantities are equal. Whatever value we have for x to the power of 1 by p, we'll have the same value for y to the power of 1 by q and z to the power of 1 by r as well. If I assume the value of this one is 5, I mean the value of x to the power of 1 by p is 5, then the value of y to the power of 1 by q will also be 5, the value of z to the power of 1 by r will also be 5. But I do not know whether the value of x to the power of 1 by p will be 5. So because I do not know the value, I assume the value of each quantity as k. So all these three are equal to k. So then we get x to the power of 1 by p is equal to k, y to the power of 1 by q is equal to k, z to the power of 1 by r is equal to k. Okay, so from these three equations I have to get the values of x, y and z. Once I get the value of x, y, z, I can substitute into the second information, that is x times y times z is equal to 1. So when I substitute the values of x, y and z into the second equation, I may get a chance to get the value of p plus q plus r. Okay, let's try to get the values of x, y and z. Okay, let me take this first equation, x to the power of 1 by p is equal to k. I need the value of x, so I have to remove this exponent 1 divided by p. Okay, so if I switch the exponent 1 divided by p to the right side of the equation, it will become its reciprocal, then we'll have k to the power of just p, because the reciprocal of 1 divided by p will be p. So whenever we switch the exponent from one side of the equation to the other side, so there is the exponent will become its reciprocal. Okay, now we can do the same thing in the second equation, the third equation. When I do so, I get y is equal to k to the power of q and z is equal to k to the power of r. Okay, now I got the values of x, y and z. I can substitute the values of x, y and z into the second equation, that is x times y times z is equal to 1. So k to the power of p times k to the power of q times k to the power of r is equal to 1. Okay, now these three terms are multiplied with the same base k, so we can take the base once, we can add the exponents. So p plus q plus r. So whenever two or more terms are multiplied with the same base, what we can do is we can take the base once and add the exponents. Here the value of this term k to the power of p plus q plus r is equal to 1. For what value of p plus q plus r, the whole thing, that is k to the power of p plus q plus r is equal to 1. It's very simple, that is p plus q plus r is equal to 0. When p plus q plus r is equal to 0, we will get k to the power of 0. So anything to the power 0 is equal to 1, so k to the power of 0 is equal to 1. So this statement, I mean this equation will be true only when p plus q plus r is equal to 0. So the value of p plus q plus r is equal to 0.